Let knowledge flow like a river without any hindrance. Don't make it like a stagnant pool. Design and analysis of sort tight column. Hello everybody, I'm PS Strategy with you. Today I'm going to explain you how we can prepare a Excel proforma for the design of r.c.c. sort tight column. I hope you are going to enjoy this video. Before start of the lecture, please like, share and subscribe my channel. Square, rectangle or rectangular column with different types of load. And this is circular column. Column length and unsupported length. Say L is the length of the column and unsupported length means L minus depth of the beam. Condition for short column Lx, that is unsupported length in x direction, should be L minus d2 and in z direction L minus d1. Maximum of L2 by Lx and d1 by Lz less than equal to 12. Square or rectangular section. Length is equal to L, depth is equal to D, width is equal to B, dia of member phi 1, dia of binder phi 2, clear cover CO. J is the unit weight of concrete, AG is equal to gross area is equal to B into D, self weight SW is equal to G into L into AG. Circular section, length L, diameter D, dia member phi 1, dia binder phi 2, pitch or spacing of binder SH, clear cover CO. G unit weight of concrete, AG gross area pi by 4 d square, core dia DC is equal to D minus 2 into CO minus phi 2, core area AC is equal to pi by 4 DC square, self weight is equal to Z into L into AG. Binder for circular column may be hoop type or helical type. We need to calculate the volume of helix VHE per turn. Cross-sectional area of helix is equal to ASH is equal to pi by 4 phi 2 square. Length of helix LSH is equal to N into square root of CH square plus SH square, where N is equal to number of turn, here it is 1. CH is equal to average circumference is equal to pi into DC plus phi 2. Volume of helix per pitch HE is equal to ASH into LSH. Volume of core VC is equal to pi by 4 DC square into SH. Gross area by core area of column is equal to AG by AC. Ratio of volume of helical reinforcement to the volume of core VHE by VC should be greater than equal to 0.36 AG by AC minus 1 into FCK divided by FY. Advantage of using helical binder over hoop binders. According to 38.4 of the code, the strength of the compression member with helical reinforcement is 1.05 times the strength of a similar member with lateral ties. Therefore, given load and moment should be divided by 1.05 before referring to the chart. Factor load on column. Axial load is equal to PU, moment around XX axis MUX, moment around ZZ axis MUZ. When MUX is equal to MUZ is equal to 0, then it is axially loaded column. When MUX or MUZ greater than 0, it is uniaxially loaded column. When MUX and MUZ both are greater than 0, it is called biaxially loaded column. Design of axially loaded column. Step 1. Minimum eccentricity. E minimum in both directions, E minimum x is equal to Lx divided by 500 plus d by 3. E minimum z is equal to Lz by 500 plus d by 3 subject to minimum of 20 mm, where Lx and Lz unsupported length in x direction and z direction. If E minimum x less than equal to 0.5 d3 and E minimum z less than equal to 0.05 b, then we can follow the formula Pu is equal to 0.4 FCK into AZ plus 0.67 Fy into ASC, where Pu is equal to axial load ultimate and Ag is the gross area of the concrete and ASC is area of reinforcement. For column with uniaxial bending, Pu is equal to assumed axial load, Mu is equal to assumed uniaxial bending moment, Puz is a calculated axial load, ultimate capacity of the column, Ag is equal to gross area of the concrete and ASC area of steel. Once again, if the minimum eccentricity less than equal to 0.05 B or D, then we can put Pu calculated is equal to 0.4 into FCK into Ag plus 0.67 Fy into ASC. Otherwise, by using the chart, we have to calculate the value of moment capacity of the column. Compression member subject to biaxial bending. Say MUX and MUZ are the moments around X and Z axis. MUX1 and MUZ1 are the maximum uniaxial moment capacity. PU axial load. Once again, if Emax less than equal to 0.05 maximum of B or D, then PU cal is equal to 0.4 into FCK into Ag plus 0.67 Fy into ASC. Otherwise, we have to find out the value of MUX1 and MUZ1 from chart, where PUZ is equal to this value. And after that, we have to prove that MUX by MUX1 whole to the power alpha n plus MUZ by MUZ1 whole to the power alpha n less than equal to 0. Alpha n is the exponent whose values depends upon Pu by Puz. When Pu by Puz greater than less than equal to 0.2, then value of alpha n is 1. When the value greater than equal to 0.8, alpha n is equal to 2. Intermediate value we can find out by interpolation. Now I am going to solve the problem given in SP 16 1978 1999. Example 5, the axially loaded column. Determine the cross section and the reinforcement required for an axially loaded column with following data: factor load 3000 kN, concrete grade M20, characteristic strength of reinforcement 415 Newton per millimeter square, unsupported length 3 meter. Example 6, square column with uniaxial bending. Determine the reinforcement to be provided in square column subject to uniaxial bending with following data: size of column 45 by 45 centimeter, concrete mix M20, characteristic strength 415 Newton per millimeter square, factored load 2500 kilonewton, factored moment 200 kilonewton per meter. Circular column with uniaxial bending. Determine the reinforcement to be provided in a circular column with following data: diameter of column 50 centimeter, grade of concrete M20, characteristic strength M250 Newton per millimeter square. Rectangular column with biaxial bending. Determine the reinforcement to be provided in a short column subject to biaxial bending with following data: size of column 40 by 60 centimeter, concrete mix M15. Today M15 grade of concrete is not applicable for any major construction. Characteristic strength of reinforcement 415 Newton per millimeter square. Factored PU 1600 kilonewton. Factored moment acting parallel to larger dimension MUX is equal to 120 kilonewton. Factored moment acting parallel to shorter dimension MUY. Now I'm switching over to Excel spreadsheet for the numerical calculation. Welcome to my Excel spreadsheet for the design of short r.c.c. column. My first problem, axially loaded column. Size we have considered 600 by 450, length 3 meters, cover 40 mm, M20, FY 415, factory load 3000 kilonewton, moments 0, 0. Here I have introduced partial factor of safety. If it is working load, then we require this, otherwise it will be 1. Now, still considered 1% to 12, not 1%. Okay, 1%, PU 3000 and PU1 2908. So we have to increase little bit seal. Not okay. Now it is okay. This is 3020 kilonewton and this is 3000. This value is more than this value. So design is okay. Status of the design okay. And here is our design summary. Problem 2. Square column with uniaxial bending moment. Size 450 by 450, length 3 meters, grade of cover 40 mm, grade of concrete FCK 25, FY 500, FY 415, secondary reinforcement also 415, load 25002500 kilonewton, MZ is equal to 200. Now you have to change here. First we have to decide which kind of column we are going to design. It may be circular or it may be rectangular square column. Now distribution 0.08. So we have to put here 0.08 and here no value. Look here, this moment capacity is less than actual moment. So we have to change the reinforcement little bit. Once again, 4 number 20, 1.55%, 0.6 and 4.490. 0.09 required value as per chart. 0.495, that is 0.5 and 0.6 This is 6, 500.44 and 0.05.44. That means here 0.05 here. Look here 0.09. Design is okay. Now I'm going to analyze circular column with uniaxial bending with diameter 500 mm, FCK 20 Newton per millimeter square, Fy 250 Newton per millimeter square, Fy 250, secondary Fy 250, dia 500, B will be 0, and reinforcement distribution, circular distribution, load 1600, mu 125, 51. So we require the value of mu by FCK BD cube is 0.051. Now look here from chart, d dot by d, 0.1 Fy 250, okay. Our Pu by FCK d square, that will be 0.32, that will be here, and 0.7, P by FCK 0.7, 0.7, this is 2, 4, 6, and this one, 0.3, 0.0246. It is very close to 0.045. 0.045, so we have to increase little bit. 500 percentage of steel, 1.48, 0.07, 32.07, 46, very close but not exact, 0.32, 0.68. Now it is, we can say 0.055. Our design is okay. Now I'm trying square rectangular column with biaxial moment. Size of the column rate by 400 mm. 400 mm, length 3 meter, clear cover 40 mm, load 1600 kilonewton, MUX 90 kilonewton, MUZ 120 kilonewton. Rectangular column. I'm considering equal distribution. 6 number 18.5, 0.055, so okay, 0.07. This value should be 1. 0.08. We require this value 0.08 according to chart. Look here, it is when we are putting here 15 M grade of concrete 15, then we are getting some warning because M15 grade of concrete is not suitable for this type of construction as per our code. E by FCK 0.1. This is 468.1 here, 0.1 and 4.4, that is here 468.1, that is 1.0, sorry, 0.12, 42468.1, this is 0.11. Our design is okay. And this is all about my semi-automatic column design with the help of chart 27 to chart 62 of SV16 1978, 11th repeat March 1999 and Excel spreadsheet. I hope you enjoyed this video. My next video will be on pile design. Please don't forget to subscribe my channel and also evaluate my performance with your valuable comments. Thank you.